right, ladies and gentlemen, today what we're going to do is take a look at rhombuses, rectangles, and squares. And I would assume that the majority of you recognize rectangles and squares. But what these are known as special types of parallelograms. So we're going to use the properties of those special types of parallelograms to start identifying them. All right, so if we take a look at the vocabulary, a rhombus is a parallelogram with 4 congruent sides. Remember, a parallelogram has to have opposite sides congruent. So we could have 2 different side measurements. With a rhombus, all 4 sides have to be the same measurement. For a rectangle, it's a parallelogram with 4 right angles. So remember, we have to have opposite angles congruent. So we saw in our quiz, we have a lot of different angles there. But here they have to be 4 right angles, so all of them are the same. And now a square is what I would call kind of like the marriage, the combining of a rhombus with a rectangle. A square is our most special parallelogram, I think of, because it has the 4 congruent sides and the 4 right angles. So let's take a look here. We're going to use the properties of special parallelograms. We know that ABC is a rectangle, so we need to find AD and AB. So let's do that first. AD is opposite BC, and so using the fact that it's a parallelogram, we know that it still has to be 5 because the opposite sides of the parallelogram are congruent. And so AD equals the BC, the side opposite of it, which is 5. We know AB is opposite DC, which equals 8. So we're still able to use those same properties that we used earlier in the chapter. It says to find the angle measurements. By that definition, there's 4 right angles, and so because all 4 of them are right angles, they all equal 90 degrees. All right, so here's your checkpoint. We know that this is a rhombus, simply by the information given to us. And so you need to find QR. This should tell you you're looking for a side, because there's only 2 letters there. RS is a 3rd side, and SP is the 4th side. So use your definition of a rhombus to find those 3 missing sides. So you are going to do now, and we will check in class. All right, now we're going to have some of these corollaries. Corollaries are a little bit different than theorems because they're just things that we understand, things that we can assume from a given theorem. So for the rhombus, if a quadrilateral has 4 congruent sides, all right, so if we have 4 congruent sides, such as the diagram there, let me get the word side in there, sorry guys. 4 congruent sides, then it's a rhombus. So it's similar to what we did in 6.3. We take these definitions and we work backwards. We know a rhombus has 4 congruent sides. We know 4 congruent sides means we have a rhombus. So notice there's no comma in here. AB is congruent to BC, which is congruent to CD, which is congruent to AD, which means all 4 of the sides are congruent to each other. We then have a rectangle corollary. So if we give you a picture of a rectangle and it has 4 right angles, then you're going to tell me that it's a rectangle, and that's the best that you can tell me. Notice there's no measurement saying that the sides are congruent, so I don't know that it's a square. If all I see are the 4 right angles, then I know I have a rectangle. And for the square corollary, you're putting those 2 together. So if the quadrilateral has 4 congruent sides and 4 right angles, then it's a square. So the square, that's why it says kind of like that most special. It's the best one because it has both of those characteristics. So in order to call it a square, I have to see the congruent sides, and I have to see the 4 right angles. So the square takes the most to prove. All right, so let's take a look at what they want us to do with these. So they want us to be able to identify special parallelograms. So they want us to take a look at the information and see what we know. It has 4 sides, so it's a quadrilateral. When we look at it, it has 4 right angles. So when we look at what we're given there, the 4 right angles went with our rectangle corollary. The sides are not congruent. 5 does not equal 3, so we know that it is simply a rectangle. Because all the sides are not the same length, you know that it is not a square. So they kind of talk you through what I already said there. So you're looking for angles and for side lengths to determine where we follow. So here's your checkpoint. If we take a look, I don't have any angle measurements. So if there's no angles, that means the only thing I can possibly look for is a rhombus. When I look for a rhombus, I'm looking for 4 congruent sides, and I happen to have 4 sides that are all 4 units long. So what can we use? Or what can we name this? This is simply a rhombus. So we're not having to explain our reasoning there, we just have to define it, tell us what we see. Number 3, you're going to do now, and we'll check in class. All right, theorem 610. So these are things that we can go back and prove. But the theorems of a rhombus, the diagonals of a rhombus bisect each other because they are part of, it's a parallelogram, so it still has that property. But what we know is that they are perpendicular. All right, so we're still going to have these 2 segments congruent and these 2 segments congruent. But what we're also going to have is inside here, we're going to have created 4 90-degree angles. So we can create 4 right triangles. Those will be things that we use a little bit later on. So let's take a look here. They want us to find the value of x. So by theorem 610, we know the diagonals of the rhombus are perpendicular. So we know angle BEC. We know this angle is a right angle. So triangle BEC, when we look at the entire triangle, we know that it is a right triangle. So I'm going to draw in that 90-degree angle. So how does that help us? Well, remember, our triangle sum is 180 degrees. All right? So when we look at that, we know in a right triangle, the angles are complement. All right? So they're taking through this. The x has to equal 90 minus 60, so it equals 30 degrees. If you don't remember that they're complements, you can still do what we've done earlier. Do 180 minus the 90 plus 60. Add 90 plus 60 together. Do 180 minus 150. And that still gives you your 30 degrees. So we can know that 60 and x have to equal 90 because that's all that's left in our triangle. Or we can use 180 and subtract off the angles that we know. All right, we know that the diagonals of a rectangle are congruent. So not only do they bisect each other, but what we know is that AC is congruent to BD. So when we think about what that means, these bisect each other. And because they're the same length, we have 4 congruent segments inside there. So let's take a look at what they want you to do with that. Using the special properties, you nail 4 pieces of wood together to create a 4-sided frame. So we have a piece of wood here, 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 and here. So here's our frame that we've created. What is the shape of the frame? So we want to know, is it a rectangle? Is it a square? Is it a parallelogram? So when we look at that, we know that the opposite sides are congruent. 4 is equal to 4 and 6 is equal to 6. So the first thing we can say right now is that it's a parallelogram. We don't know that we have 90-degree angles. But if we look at part B, it says the diagonals measure 7 feet 4 inches. So one of them is 7 feet 4 inches. And another one is 7 feet 2 inches. So they ask us, is the frame a rectangle? And we say, no, it's not a rectangle because diagonals are not congruent. So just because it looks like a rectangle in the diagram they give us, we need to label all of the information that we have. We're given a diagonal of 7 feet 4 inches. We're given another diagonal of 7 feet 2 inches. And so because they were not equal, we cannot say it's a rectangle. So the best shape that we can use to describe this is simply a parallelogram. All right, so which theorem did we just use there? That was theorem 6.11. All right, so let's take a look at this. ABC has the property shown in the figure. Is the statement true or false? Explain. So the properties mean we have 4 right angles. And because each of the 4 sides only has 1 tick mark on it, that means all 4 sides are congruent. So is the statement true or false? ABC is a rhombus. I'm going to say true and explain why. It has 4 congruent sides. And that's all I have to be able to find in order to call quadrilateral a rhombus, is 4 congruent sides. If we take a look at the next statement, it says ABC is a parallelogram. I'm going to say true. One reason I could say is simply because it's a rhombus. As soon as you name something a rhombus, a rectangle, or a square, it's automatically a parallelogram because it's a special those are special types of parallelograms. But what I can use is I can use some of the features I see here. I see opposite sides congruent because these 2 sides are congruent and these 2 sides are congruent. The other thing I see are opposite angles are congruent. All right? So that's what it means to determine if the property shown makes a true statement and explain why. So for number 6 and 7, these are on your own. Okay, so you are going to do now, and we will check in class. All right, that's it for today. We'll take a look at this when you return to class tomorrow.